Unit 10, Day 1 video notes, completing the square and the quadratic formula. Okay, first example here. We have an equation where there's a perfect square in it. And we have part of the left side over here factored as a perfect square. And we're going to take advantage of that perfect square to solve it. This is a different technique than what we've used before, where we set it equal to 0 and factored and solve. So let's try this and see how it looks. Okay, so the first thing is that I need to get rid of all of the other terms that are on the same side as my perfect square. So I'm going to add this 15 to both sides of the equation, giving me now 2 times 3x minus 5, that quantity squared, equals 8. Okay, now to get this perfect square by itself, I'm going to divide by this 2 here. Divide both sides by 2. Let's extend the page. Okay, so that's going to give me, well, those of course are going to cancel out, so now I have 3x minus 5, that quantity squared, equals 4. So now I'm going to take the square root of both sides. And when I do that, I need to make one side of the equation. We always take the other side of the equation, make that plus or minus the square root of, because in doing this I introduce the possibility that there's that other one. So now the square root and the perfect square cancel each other out, so on this side I now have 3x minus 5. And over here the square root of 4 is 2, so it's plus or minus 2. Now, that plus or minus means that there are actually 2 equations here, and I'm going to break it apart into those 2 equations. One of them is 3x minus 5 equals 2, and the other one is 3x minus 5 equals negative 2. And now we'll solve each of those equations. So over here, I'll add 5 to both sides of the equal sign, giving me 3x equals 7. And then, well, here, let me back up just slightly here. And my calibration's off pretty badly, isn't it? Okay, so I'm, of course, dividing both sides by 3, which gives me x equals 7 over 3. Now, over here, same thing. I'm going to change colors here. I'm going to add 5 to both sides of the equal sign, leaving me with 3x equals 3. So if I divide both sides by 3, I get x equals 1. And so now my answer is x equals, and why did I put that comma in there? Let's try this again. Equals 7 over 3 and 1. Okay. Now, same problem, except I've changed some signs here, and let's see what happens. Oh, I don't know where that example 22 came from. Let's see if I can get rid of that. No, I can't. This is example 2. Not sure where that example 22 came from. Okay, so same thing. We're going to subtract 15 from both sides of the equation. And when I do that, I'm going to get 2 times 3x minus 5, that quantity squared, equals negative 8. And then I will divide both sides by 2. Which will give me 3x minus 5, that quantity squared, equals negative 4. Now, we're going to take the square root of both sides. And of course, there's that plus or minus that we have to put in. So now, here, the square root and the square cancel each other out, and we've got 3x minus 5. And that equals plus or minus, we have an issue. We have plus or minus the square root of negative 4. The square root of a negative number is not a real number. It's an imaginary number. We'll deal with that in Algebra 2. It's a tool that we've invented for solving unsolvable problems. But it's not a real number. We can't do this. And so what do we have? We have no real solution. Now, what we've just been doing is part of something known as completing the square. And we're going to utilize that to derive a really powerful tool, the quadratic formula. So let's try this and see what it looks like. We're going to start off with a very generic equation. Our coefficients are all variables. We have letters. And that is going to allow us, when we get to the quadratic formula, to be able to plug those coefficients in. This ax squared plus bx plus c equals 0 should look very familiar to all of you. Okay, so the first thing I need to do, oh, and that wasn't the one I wanted. First thing I need to do is get this c over to the other side of the equation. So I'm going to subtract it from both sides, giving myself a x squared plus bx equals negative c. Okay, so now, in order to complete the square, I need to get rid of this a coefficient. So I'm going to divide both sides by a. And I'm sorry if my a looked way too much like a 9 here. Let's fix that. Okay. So when I do that, I am now going to get x squared plus b over a times x equals negative c. Sorry, that was supposed to be a c. Let me fix that. Put in my x equals negative c over a. Now, let's take a look in our box. If we're creating a perfect square here, and that's what we want to do, is create a perfect square so that we can use the same method we've been using. Well, my x squared, of course, goes there. And these two boxes that we combine, for this to be a perfect square, they need to be exactly the same. So I'm going to take this middle term and I'm going to cut it in half. I'm going to divide it by 2. I'm going to multiply it by 1/2. So I'm going to put a 2 into the bottom of my fraction here. So I'm going to get b over 2a x. I'm going to put that in both of these. Okay, now, to make this work, let's see what we need here. Well, those are both going to be x's. And that has to be b over 2a times x. And so does this. b over 2a times x. So in here, I'm going to get b over 2a, that quantity squared. Okay, so now I'm going to add that to both sides of the equation to create a perfect square. So now I have x squared plus b over a x, and then I'm going to add to both sides of the equation here, plus b over 2a squared, and I'm going to add it to the other side of the equation as well, b over 2a squared, and then I've still got this minus c over a. Okay, now on the left side of the equation I now have a perfect square, and I know that because I have it up here with the box, and I'm now going to convert it into its factored form. So let me write it in its factored form, which is x plus b over 2a squared. Now over here, let's go ahead and square this b over 2a. I've got b squared over, let's see, if we square 2, we have 4, and a squared minus c over a. Okay, we need a common denominator, and that common denominator is going to be 4a squared. To get that, I need to take this c over a, and I need to multiply it top and bottom by 4a. So let me do that. So on the bottom, I'm going to multiply by 4a, and I'm going to do the same to the top. Okay, so now I have x plus b over 2a, that quantity squared, equals b squared over 4a squared minus 4ac over 4a squared. Notice I put my coefficient out front and my variables in alphabetical order there. Okay, so I'll extend this page again. I can now combine like terms there. Let me bring this down. X plus b over 2a, that quantity squared, equals, and now I have b squared minus 4ac over 4a squared. Okay, It is now time to take the square root of both sides. And again, when I do that, I'm introducing this plus or minus. So let's take a look at this. So over here, the square root and the square cancel each other out, and I'm left with x plus b over 2a. And then over here, I can break this apart into plus or minus the square root of b squared minus 4ac over the square root of 4a squared. Okay, that 4a squared, that's a perfect square, so we're going to deal with that next. So let me bring down my x plus b over 2a equals plus or minus the square root of b squared minus 4ac. And now on the bottom of my fraction, the square root of 4 is 2, and the square root of a squared is a. Okay, I am almost done. We now need to get this x by itself. So we're going to subtract b over 2a from both sides. Okay, so on the left I now have x equals, and then on the right I'm going to put this minus b over 2a out front. Minus b over 2a, and then plus or minus the square root of b squared minus 4ac over 2a. Notice I already have a common denominator, so that makes the next step fairly simple. I can combine these fractions, giving me x equals negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Very, very powerful shortcut that we use in algebra. Keeps us from having to do completing the square with all problems. So here it is typed out so that it's much easier to read than my handwriting. And I might add, this is something that I will never forget. If for no other reason than a few years ago, I took the tune of a song that I knew, and I put the quadratic formula, the tune of that song, and then I ended up singing it in the talent show a couple of years ago. And I imagine most of you were not there, probably all of you were not there. I imagine there are very few of you that were out options then, although I know of at least one. But I guess I'm going to give you the opportunity to hear it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So as a result, I will never, ever forget the quadratic formula. Now, let's see how we use it. Up here in the upper right-hand corner, I've given the formula to you, and we just need to take this and plug it in. Well, I'm sure you're all familiar, but let's remind ourselves. There's a coefficient here that's not written, that's my a. The coefficient, of course, is 1. This is my b, and this is my c. Should all look familiar to you. And sorry, I was trying to circle the whole 11 and I didn't do a very good job of it. So let's go ahead and fix this. There we go. Okay, so now we're going to plug it in. We have x equals negative. Now my b is negative 6, so I'll plug in that negative 6. Now, notice I now have minus negative, or a negative negative. We'll deal with that in a minute. Okay, plus or minus b squared, well, the square root of b squared, my b being negative 6, and we're going to square that, minus 4 times a was 1, and c is negative 11. Okay, it's the square root of that whole thing. And then all of that is over 2 times, and a was 1. Now that we've plugged it in, we just have to work out the calculations. So of course, a negative negative 6 becomes positive 6. Here, let me put in my x equals. Okay, it becomes a positive 6 plus or minus, and the square root of. Now, negative 6 squared is a positive 36 minus 4 times 1, that's 4, and then times negative 11. Well, times the negative changes that to plus. 4 times 11 is 44. Okay, and then over 2 times 1 is 2. Okay, so x equals, let's bring this up, 6 plus or minus the square root of, now let's see here, 36 plus 44 is 80. And that's over 2. Okay, we need to simplify our square root of 80. So let's take our square root of 80 over here and simplify it. Okay, we will circle all of our primes. Now, let's see here. We have a set of 2's there, so its square root will be 2. Another set of 2's there, so their square root will be 2. And then we have a 5 left over. So let's move this so we can see everything. So now we have x equals 6 plus or minus 2 times 2 is 4 times the square root of 5 over 2. Now we could break this apart into 2 equations to solve it, or we can just take both terms and divide them by 2, distribute the dividing by 2, giving us x equals 3 plus or minus 2 times the square root of 5.